I'll get started a little bit while he's figuring that out. Like Orv said, my name is Brent Johnson, and I think it's important for everyone to understand that basically I wear two hats. My first job is being a farmer in Iowa. I raise corn, soybeans, cattle, and live on a century farm. We've been doing a lot of innovative things over the years. And a few years ago, 2006, my wife and I, through the need to find an independent viewpoint, basically started an independent crop consulting company. And we started very simply just dealing with fertility information and variable rate technology, dealing with variable application of fertilizers. The focus of the company, and everybody I've hired since then understands where the company started from, and still to today, we don't sell any seed, we don't sell any chemicals, we don't sell any fertilizer. Our only intention with our crop consulting company is to inform and educate our customer, the farmer. So that's the focal point we come from. Everything we do on the crop consulting side, I really try to ground truth a lot of that from my farm side, and a lot of the things that we've talked about, implemented tools, technology, we have used on our own family farm. So, yep, we're good. So in order to know where we're at, I like to frame in where we've been. It's important for me to understand. So the history of a UAV, or as Terry said, a UAS, it seems to us that it's got a very short history, and I was actually pretty surprised when I figured out how old it really is. In August 22nd of 1849 was the first history of a UAV, and that was the Austrian army used to bomb Venice. Now they didn't have any control over it, but they did load up some balloons and floated them over the city, and were successful in that navigation. Unfortunately, at the time, the winds changed, and they also bombed themselves in the same term. But for 100 years, the UAV industry was really used in the war industry, and still today there's that perception that it's a weapon of war. It's a bad thing. And in the 50s was the first time that anybody had actually got the idea of using it for something non-destructive. So over 100 years, it was used only for destruction. Okay, and in 1983, several years ago now, it doesn't seem very long ago, but the first high-altitude drone was successfully launched. And it actually produced an alternative energy source to power helicopters, and it was successful at its job. It was just cumbersome, and there was some other things going on globally that it never got caught on. But it was rather large, almost 100 feet, and it flew extremely high. So, and a little closer here in history, in 1998 was the first UAV experience across the Atlantic Ocean. So what we think here locally is something that's only been around for just a few years, maybe 10 years, 15 years, has actually been around an extremely long period of time. Dealing with different types of UAVs, and you've seen them around, you'll see more of them. There's the wing style, and there's the quadcopter or hexacopter multi-rotor style. They each have their benefits, they each have their disadvantages. And it's important for everybody to understand what the purpose of your flight is and what your goals are out of what you're trying to do. They each have a purpose, and they each have their fit. For my company, we ended up choosing the wing style, and as the picture shows, we are a SenseFly distributor. That's the vehicle that we chose that felt our purposes for crop consulting, broad acreage, high resolution of imagery, and a really nice level of data management from a company who has a long history in the UAV industry, being that they are started in the European sector. some of the things to think about when you're going through there, which platform do you need a wing, or do you need a multi-rotor style platform? Understand the GPS systems that are on there, because that's going to be important. The autopilot systems, it is a fairly new industry in the United States, and there's plenty of stories of, my UAV just took off and I couldn't go find it, and there's lots of those out there. So the autopilot system on board of that UAV is going to be an important part of what you're dealing with. How it's going to communicate back to you as the operator is also important. Is that 2.4 megahertz? Is it a wire? What is that communication source, and how are you going to work with that? The sensors on board. Terry talked a little bit about the sensors. Cameras. There's different types of cameras. He talked about multispectral, hyperspectral, brands, or there's modified lenses within those. So understand this type of sensor that you're going to need for the application you need. He talked about near infrared as a needed sensor. That's going to be important for agriculture, but if you're in surveying or real estate, that's not the sensor that you want. You want more of a true color aspect. Data processing. This is probably the biggest challenge when it comes to the UAV industry right now, is how do we deal with, how do we process, how do we understand, interpret, store, archive all this information. And it is a big challenge, and it's something that if you're going to end up determining that you're on you want a higher end tool, and you want a UAV capable of collecting data, this is going to be an important consideration for you. Integration, legal, and just the simple operation. So there's more to it. It's more than just going to the hobby store, buying a helicopter, putting a camera on it, send it up, and away you go. So lots of things to consider when you're choosing the tool for your application. Along with that, there's different types of images. So I've talked to plenty of people who have put GoPros on things and gone and taken a video, and that's really cool and kind of neat. And GoPros have a lot of attraction right now because they're kind of the new hot topic techie camera thing, and it's fun to say I put a GoPro on something and go take a video of it, and it is neat and it is valuable at some aspects. We chose a platform that allowed us to collect still images. And for us, that image factor gave us a snapshot in time that I can measure, that I can quantify, that I can work with. Now, there's also needs to be an understanding that these are images, and the next slide is what I'm interested in working with is actually geo-rectified 3D data. Terry talked about it a little bit early on. We're still going to interpret the 3D data as an image, but it's actually in a very intense data layer. And if you just take a picture, you just take a video, you have that image, and it is valuable, and it does gain you that perspective. But if you're interested in going to the next level, dealing with precision agriculture, implementing that technology, putting it in a layer source, it needs to be a data source. Now we see it as a picture because that's how we interpret it, but it is data. It does have reflectance properties. It does have an X, Y, and Z place in the world, so it does have vertical accuracy. It does have horizontal accuracy. So you can measure from it. You can measure slopes. You can measure altitudes, watersheds. You start thinking about your picture and data in 3D in space and time, then it starts to really get your wheels going. Currently, where we're at in agriculture. So this, practically speaking, these are really in use or very close to being in use today. Measuring all these things, and Terry touched a lot on these, and it's not very hard to conceptualize how a tool like a UAV, a UAS, can help a consulting business work and achieve some of these goals here. Seeking better measurements. So if you start at the top, in our precision ag company, it's almost a timeline of bullets here. At the top, we started working on a full field instance. How do you treat this field, and That method was good, say, 30, 40 years ago. The back 80 tends to be a little poor, something like that. Now, in the 90s, we started getting into GPS and grid soil sampling, some of those types of tools. So we started breaking down that management zone and getting to work within a field's boundaries and treating site specifically how you were to manage a different field. Starting to then work in zones, so you're adding soil types, you're adding EC data, yield data, whatever you might do to more define your working area. Working with yield data, that came along here just not too long ago as planted and as applied data. Now this really has some interesting things as these companies are really pushing the planter technology. We are now able to map basically by the row and just about to the kernel as to where kernels are dropped, what's going on with it, what was the planter doing. So that planter tool is getting to be a very precise tool. And georeference scouting, that's coming in really quickly now with the advancements of the UASs. Go out, fly a field, and now I can identify a spot instead of sending out a scout, and maybe he goes to the back corner, maybe he doesn't, he just looks for a problem. Now he's got a target. He's going to be more efficient with his time, and we can do a better job of recording and understanding, measuring those stresses, all those things. Now that whole list, get down here towards the bottom, and it says simple decision follow through, if any. We've done a really good job of collecting a lot of information, and by owning a precision ag company, I see my customers, they're really good at, they want the information, they want the gadget, they want this and they want that. And when it comes down to actually making a decision from that data, well, yeah, that sounds interesting, but I got to buy this seed bag from that guy, and we're going to go and do this. And that's my fertility program. I've always done it that way, or however that might work. So the concepts of using that information to make an operation more profitable is very close, but in reality, there's very few operations who actually implement that to the degree that we're capable of today. The next level of precision, okay. Using some of these UAVs, some of the targets that we've identified as a professional company, plant identification, measuring population, measuring emergence. So I talked about how specific the planters are getting and where we know where the kernels are dropped. Now can we use a UAV to actually measure where the crop has emerged? So can we find emergence patterns? Can we query an image and say my population isn't up to par in this part of the field? How big of an area is that? Go send a scout out. Yes, it is poor emergence. Okay, it was this big. You need so many bags of corn to go replant. This is the area that you're going to. It becomes very easy to start to manage your replant situations. Vegetative health, NDVIs, and using the spectral responses beyond what we can interpret, the red edges, the near infrareds, the thermals, some of those reflectance properties. Single band analysis, multi-band analysis, it all comes into the interpretation of that data and what you're trying to get out of it and how you're going to try to relate that to the crop that you're growing. 3D information, I touched on this a little bit, putting that specific pixel in an X, Y, and Z place in time. Am I looking at stress on the north slope or the south slope or the peak or the bottom? 3D, topography, those types of informations are very quickly being integrated into data layers. And real follow through on data observations. I really think in the next 5 years, this bullet right here is really going to gain some traction. We're actually going to make some real decisions from the data, implement it into the equipment that's capable of doing that. So I think that's a huge growth potential right there. Just a screenshot of some of the ideas. completely made up, but it's a field that we flew, just theorizing how we might use that. And you could think of it either way. I mean, we could go out and scout first, fly it, identify that stress, and then measure the area, the intensity. Or you can go out and fly first, find the problem areas, send a scout out, what is that problem, measure it, define it, and work with it. So in an instance like, we're approaching pollination here. So are we seeing some fungus stress coming in? Can we go fly a cornfield before we actually call the crop duster and know that we have this stress, or where is this stress? A little bit later in the year, we've got aphid pressures coming. Is that in my field? Is it not in my field? It's a hard pest to scout for. We don't know where it is. What's its intensities? What's its patterns? Is it going to change over the next couple days? We'll go measure that in multiple flights. Finding machinery issues. There was a question back there about return on investment on the UAV. The most immediate return on investment that I can think of is actually finding machinery issues. And these are real examples that we found last year. 2 different farmers. One guy over there with the small blocks, he's actually a very intelligent, very meticulous type of farmer. And he was watching his anhydrous pressure gauge, and it would reach pressure before he was actually getting to the rows. And then later on, we actually flew over and saw he might have been getting pressure at the gauge, but he wasn't getting pressure at the knife until about 40 feet into the field. Now, he couldn't see that. You can't see that stress from the ground. You're walking around in the corn. That's not visible. But now we can measure that. And one thing I didn't do, and I wish I would have gone out into that under-fertilized area, taken a yield estimate in there, gone right next to it and taken a yield estimate in the properly fertilized area, and done some math to help him figure out that decision to turn your anhydrous switch on 40 feet sooner is you can put that into your return on investment. This other one is actually a plugged anhydrous knife, and again, you couldn't see that stress from the ground. We didn't see that until we flew it. And if you were a farmer at harvest time and you were to go through and harvest this, you cannot find that with the combine, because you're averaging 8 rows, 12 rows, whatever your header width is. So you've got a great big average of that, and you can, I don't know if it shows up properly or not, but that stress is every 12th row is under fertilized. So a significant portion of his farm is under fertilized, and if he would have just harvested that as normal, he might have gone to the seed dealer and say, that hybrid didn't do very well. Well, in this case, it wasn't the hybrid's issue; it was his fertility program. NDVI. Terry talked a little bit about NDVIs. The top picture is the near infrared image, and this is a hayfield right at our place. And then this is an NDVI image taken from that, an NDVI calculation. And you can see the red spots. And and I can tell you that if you're walking around out in that hayfield, you're not going to see a hay stance difference. But what you can see is the reflectance out of that hay crop is a lot less. So I know that hay crop is about 7 years old now. I'm starting to lose it in those areas. So something to watch, keep track of. Sequential flights through a season. I talked like the images are all geo-rectified coming out of the tool that we chose. So through some software, we actually just wiped off the second flight, which is the one that was taken August 5th, so that you could see the June 6th flight last year underneath it. So we weren't just lining up pictures, we were actually just wiping off some of the image that covered up the previous flight. So if you turn this into data, now I've got multiple data layers. I can see that some of the responses that I'm getting in August, the drown out spots, some of those things, I could actually interpret that in June 5th. If I could have anticipated that in June 5th and had the time and the knowledge to correct that issue, could I have changed my August picture? And I think we could have. This is an area that's really pretty interesting to me, and I don't have too much experience with it, but thermal imagery. I borrowed this from a website called Air Scout, and I met Brian at another conference this last winter, and he actually uses real airplanes with thermal imagery, but he's only focused on thermal, and he says that you can learn a lot in thermal bands. Bare ground, you can find compaction areas, you can find where crops are heating up, things like that as the crops are growing for irrigation purposes, all those reasons. So my tool, I don't have the ability to add thermal to my tool yet, but it just shows the range of options that are out there. So in thinking about the light reflectance, and this, I had a lot of learning to do here in the last few years, but you know, we can only see, this graph's a little wide. Realistically, we can only visualize 450 to 700 nanometers. That's our visual spectrum of where we see a response at. And if you look further to the right, you have infrared, microwaves, radio waves, and thermals in that microwave area. And you'll actually keep on going into AC electricity. But what we can interpret as reflectance is actually a very, very narrow band of what's going on that we can train a sensor to capture. So there's different types of sensors, different types of images. We're all used to seeing a red, green, blue picture, and that's that one there. That's what we see as an image. That's a picture to us. There's other filters that you can put into the cameras to get you some of these other reflectance properties so that we can see crop stresses beyond our normal visual patterns. And the calculation for an NDVI is really nothing special. It was actually made in the World Wars. But it's just the near infrared minus a visible divided by the near infrared plus a visible. So you can get a red NDVI, you can get a green NDVI, you can get a blue NDVI. The most common for crop stresses is a red NDVI image. This is kind of a crop reflectance graph based on the reflectance of chlorophyll. Chlorophyll is the part that's reflecting on the corn plants that we interpret as that plant being green. And you can see right about 550 nanometers, there's just a little bit of a bump in that graph. That's our color green. So what we see is really green grass, really green corn. We're just seeing that little bit of a bump. Now you go into the near infrared sector, and you can see how much reflectance the chlorophyll is giving to that lens. We can't interpret that reflectance, but we can have a sensor that can pick up that. So a crop is a lot more sensitive, and they show their response more in that way out there in that area, which is why the near infrared images are so valuable to agriculture. So just taking the same slide and breaking it apart a little. This gets a little bit busy, and I know it's hard to see in the back. But again, we've got the little bit of a bump there in the green of the solid line, and then it rises quite drastically when you get into the near infrared spectrums. And there's a lot going on, and actually where the curve starts to increase, that's actually the red edge. And if you focus your cameras in the red edge, that tells you certain things about the crop, and if you're in the near infrared, it tells you other things about the crop. So it's all a matter of interpretation and how you're actually going to use that data and incorporate it into your services towards your customers. And then you get clear over into the far side of that graph, and that's where we get into the thermal imagery. Again, there's a ton of potential way out there for irrigation, variable rate watering, some of those things, and that's where that spectrum is going to be focused in. Like I said, this we do sell SenseFly, so this is their camera options in their agriculture sectors right now. And some of those graphs that I just showed you, they actually got a really nice little thing at the bottom here. Shows you where the different reflectance for those cameras are set in the properties as it means for a corn crop. Gives you a nice little cheat sheet. So you want a red edge, you want a green, you want a near infrared. So it does a nice job of defining for you what camera would be best for the application that you're choosing. Don't worry about the numbers, but my point in bringing this up is did some research heading here today, and I think I Googled crop reflectance responses, and there is a ton of work already been done. Nitrogen deficiency has been found in the 550 nanometers as well as the 715 nanometers. But this is the type of information that like Optrix and Green Seeker and those types of tools are using. Well, those are just reflectance properties. So these cameras can use those same reflectance properties to gather the same data. And there was a study done by Dr. Price at K-State that had a 0.93 R² number for equating imagery to, say, Green Seeker. This is a company up in Canada, Felix. We worked with Felix quite a bit trying to figure out which direction we wanted to go when we were trying to implement our tool. And he sent us, well, they published one of their images, and the NDVI image that was captured very closely relates to the actual yield that was captured. There's plenty of these images out there, but what it does do is it gives you that idea that you can, at some point, interpret what your yield might be and have maybe a higher definition than your actual yield monitor is going to be. I do use yield monitor data all the time. And so on one hand, I love that data. On the other hand, when I got to using the UAV systems, all of a sudden I interpreted yield data as being extremely chunky and kind of not very detailed, because we're taking a pretty wide area, averaging it all together, putting a 4-second delay into it. A lot of machine blending going through there. So it's still a great tool. But if we can define those areas better with this imagery, that'll give us a better heads up. Now the other side of that is understanding the physiology of a corn plant. The corn kernels in a corn plant are being established in that V5, V6 area. They're taking out that's when the plant is triggering the number of rows and the number of kernels in the row. So if it's seeing a stress at V5, and this is a theory of mine, I don't know if we'll see later how this holds out, but if I can measure stress at V5, can I put a real yield to that, say August 1st, when I can actually count a kernel? Put a kernel count yield estimate, calibrate the image that I did way back at V5, and then say October 1, have an 80% chance that I've got, or an 80% tolerance that I know what my yield's going to be 2 months out. I think that's got a lot of potential. I know in our part of the world, the yields coming out of the fields the last 2 years have been highly variable, and really nobody's had any idea whether they were going to get 100 bushels an acre, 200 bushels an acre. It was really, really difficult to try to guess that. It makes forward contracting difficult, makes logistics a challenge. Dealing with the imagery. How am I doing on time? Okay. Dealing with imagery. Like I said, we chose a tool that takes snapshots. So if we fly over a field and dealing with the AMA guidelines, we're trying to fly under 400 feet. You need decent overlap to stitch images together. We're probably talking 70-80% image overlap. We're on an 80-acre field. We're probably gathering 300 images, and so then what you end up with is a whole bunch of images, and that image by itself, again, means something, but the real value comes in stitching it together into a true orthomosaic image. So multiple images blended together to create a wide area image that's highly intense in data, and these get extremely large. You can sample them down, but you know, I've had for those of you with computer knowledge, I've had 500 megabyte images come out of these things before, so it's extremely large. Then another process, you can get 3D imagery. So what it does is it takes all those pixels together and it actually matches common pixels together. So it finds a similar pixel, a similar feature in each picture, and say there's 6 pictures that have that feature, and through triangulation, essentially, it knows then through that's how it starts to build its train of topography. And that process is called stereo photogrammetry, and it's just a matter of focal points at different places give you a depth perception, is essentially a real easy way to say that. So one of the guys that works for us owns a small gravel pit, and we flew over this gravel pit, and the actual true image that's in there, the blue colored one, we took with just our phone, just a phone image, and then we flew over the pit at 400 feet, and the top image, the black and tan one, is a 3D rendering model of the picture that we took. So we flew over at 400 feet, recreated the topography within that image, and then basically spun the image around, zoomed and panned until we found the picture that we took with our camera. So it shows the dexterity, the capabilities of this type of data, and it's just all kinds of points. So every pixel has just got a point X, Y, and Z in that image. And then that same type of data, you can also get the contour out of there. So then you start thinking about tiling, land shaping, terracing, some of those things, and you can build them on, of course, any type of topography contour you want. Unintended consequence here. We flew over a cornfield, fully tasseled cornfield, and you can see some compaction problems in there going north and south, where the tractor drove up and down. But there are 3 lines that showed up, and then they're tile lines. And what's important to know about this picture is this is a map of the elevation. So you're not seeing color of the corn crop, you're seeing color of an elevation. So what we found, completely by accident on this day, was we had a really wet spring a year ago, and this corn grew about 2 inches taller than its neighbor did over the tile line because it had dry feet. So what this map is showing you is the elevation change in the corn canopy height right over a tile line. So we've all heard of finding tile lines by airplane, but I haven't found one until this picture of actually mapping topography over a tile line. I believe it's used quite extensively. And Japan has got the heaviest use of these things, and they do most of their crop spraying now with this type of technology. On one hand, that scares the crap out of me that I'm going to put chemicals on this thing and go flying around, and I don't have direct control over the thing. Now you start thinking about it a little bit. If I'm applying insecticides, I'm not in that rig anymore. You know, I can fly over an area, treat an area and not worry about personal contamination, some of those things. So you can get into tight areas. Lots of advantages here, and obviously there's some disadvantages too. But the idea is that there's what's coming next in precision agriculture, and I think this is one of those areas, direct application. You can spray by these things, you can seed by them. There's the obvious. There's lots of thoughts of sending out, kind of a first wave and measuring, and a second wave of taking care of things. There's who knows what's actually going to happen. But here's a tool that's being used someplace in the world today that we can't use. So to think that the United States is ahead in this market and that we're the leaders. Actually, we're still the followers. So we're all struggling, trying to find our way, trying to learn faster than our neighbor. It's probably a better idea to go talk to your neighbor, go talk to the Japanese, go talk to whoever, and figure out where this technology is, and get ourselves up to speed, and do it in an appropriate manner. Dealing with plant identifications. I know this is really hard to see, but this bigger graph that's over here on the left by itself is a reflectance signature of multiple different crops. So there's corn in there, there's soybeans in there, there's potatoes, grass. And if we go back a few slides and we think about some of the other reflectance graphs that we had in the past, the 500, that green bump that we interpret as green, that's the little bump clear on the left side of the graph. So we have huge response, again, in the near infrared spectrum. And the point of the graph is, I'm sure you can see there's some differentiation in the crops. They all have the same pattern, they all have the same reflectance signatures, but they are different. So it's this tool that the USDA uses to identify corn versus soybeans that you've planted in your crops. So can we identify our own crops? Can we identify varieties? Can we identify weeds? Can we start using some of this information to electronically try to dissect what that image is telling us, so that we can put a management structure in place to smartly targeted deal with some of these things. Using object recognition software. I talked some about corn emergence patterns. So if we know some reflectance properties about the thing that we're looking at, am I running out of time? 5 minutes. If we know some reflectance properties about what we're talking about, can we isolate that versus its neighboring plants? And if we can, by reflectance, isolate, then we can do a better job of having the computer count and manage that information. And we kind of longhand did it this way. This is a soybean field with some volunteer corn in it. And up in the top half, I mean, that's just green on green. You can see it kind of, but it's there. You can see the corn plants. But if you get down into this blue area, we found the blue reflectance of a bean field that blue was totally absorbed by the corn plant. So we're looking at a very narrow reflectance of soybeans that reflected a blue color, but the volunteer corn absorbed that blue color. So now I can have a better shot. I haven't done it yet, but I have a better shot at getting that computer to recognize that corn plant, because it is now vastly different than its neighbors. Stand counts, same type of thing. So what I'm hoping to do is be able to count corn plants at V2, V3 for purposes of replant, emergence patterns, stand establishments, some of those types of things. So if I can segregate a corn plant from soil, and I can teach that computer to recognize that corn plant, then I've got that. Then I've got that start. So what's going to be the future? I don't know. I have no idea. Robots run around. The data is going to become huge. Data transfer in and out. Talking with a consultant, talking with your seed dealer, talking with your neighbor, whatever it's going to be. That decision being made by farmers. There's certainly going to be some farmers that are more than capable of doing that, but they are going to have to rely on some consultant in some fashion coming up, probably in the not too far future, to be able to intelligently run the equipment and implement some technology into their operations. So with that, do I have time for questions, or are we done? A couple questions. Yeah. 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 Yeah, no, that's a great question. One of my company's strong foundation pieces is that our customer owns their information. We keep everything in-house. So you'd have to pay attention to the tool that you'd implement, whether they keep their information in-house or if it's yours, or if it goes out and open for the public.
Two scenarios. You have unlimited views. How often do you fly over the fields? And number two, you're servicing a customer. What's the minimum flight per field?
Okay, so minimum flights per field, you know, basically whatever the customer wants. You know, I'm a pretty flexible kind of guy. Our company basically does what our customers need them to do. So if they just want a specific service, that's our intention to do that in the future. And what was the second?
That was the second one. The first one, if you had unlimited, how often would you go over?
Oh, yeah. If we had unlimited time, how much would we fly over? We're currently trying to figure that out right now. I've got some of my farms that are getting flown over every few days to try to collect enough information to try to figure out what is that target point physiologically in the corn plant's life cycle to make that decision. Yeah, they're going to affect. They do affect us greatly because right now I can't charge. I mean, I'm flying over my own ground. Can't. Yeah, the FAA is. They are affecting our business right now. We are, you know, flying over our own ground and my employees' ground. I can't charge for the service. I can't make a business out of it. So, in order to implement this technology and advance it at some point, you know, we're going to have to turn it into a profit center to be able to continue. So,
How about a thank you to Brent?